Stop scrolling, because if you've ever sent an email, logged into a website, or uploaded a document, you've used cryptography today. And here's the truth. Without crypto, anyone watching the network could read your data, change your data, or pretend they're you. In the next few minutes, I'm going to explain cryptography like an architect, not like a textbook. Using one real example. How an email travels from your keyboard to the other person, and where encryption, keys, and trust actually happen. Stay to the end, because I'll give you a one-sentence blueprint: encrypt, hash, sign, PKI. That makes crypto questions easy for life and for certifications. If this helps you, hit subscribe. EmpowerTechPathway is all about making tech simple, practical, and career-ready. If you've ever sent an email, uploaded a document, or logged into a website, you've used cryptography, whether you realized it or not. Here's the scary part. If your data traveled in the clear, anyone watching the network could read it, change it, or even pretend they're you. In this video, I'm going to show you the crypto building blocks that stop all three, using a real-world, sending an email, example. Read it, change it, fake it. This is for students, career changers, and business owners who want security explained at the architectural level, so it actually makes sense. By the end, you'll understand plaintext versus ciphertext, encryption, keys, symmetric versus asymmetric encryption, and how trust works on the internet. Understand crypto like an architect. Think of data moving from east to west. It starts as readable information. Then we apply layers of protection. Encrypt for secrecy, hash for integrity, sign for identity, and PKI for trust. That one sentence is the blueprint for most modern security. Encrypt, hash, sign, PKI. Let's break down the terms quickly. Cryptography. Protecting information so unauthorized people can't read it or change it. Plaintext. Readable data, like a normal email message. Ciphertext. Scrambled protected data. What plaintext becomes after encryption. Algorithm. The method or recipe that transforms data, also called a cipher. Encryption. The act of transforming plaintext into ciphertext. Key. The secret value used with the algorithm, the thing that makes the lock unique. Symmetric encryption. Same key encrypts and decrypts, fast and great for bulk data. Asymmetric encryption. Two keys, public and private, great for identity and secure key exchange. Key length. The key size in bits, often impacts resistance to brute force. Cryptanalysis. Attempts to break encryption, usually by attacking weak keys, outdated algorithms, or poor implementations. Steganography. Hiding a message inside something else so people don't even know it exists. Blockchain, open public ledger. A shared record of transactions, depending on the type of blockchain. Plaintext equals readable ciphertext equals scrambled key equals secret value algorithm equals recipe. Here's the simplest example. If I write, "Meet me at 3 p.m., that's plaintext. After encryption, it becomes unreadable characters, ciphertext. So even if someone captures the data, they can't understand it without the key. Plaintext to ciphertext with key. The crypto formula. Here's the core formula you should remember. Algorithm plus key equals ciphertext. Same algorithm, wrong key? You get nonsense. That's why security isn't just about encryption, it's about protecting the key. Algorithm plus key ciphertext. Symmetric versus asymmetric. Now the big one. Symmetric versus asymmetric encryption. Symmetric uses one shared key. It's fast, so it encrypts the bulk data. That's why we use it for files, disks, and most encrypted network traffic. But symmetric has a problem. How do two sides share that secret key safely? That's where asymmetric comes in. Asymmetric uses a key pair. Public key. You can share it. Private key. You must protect it. Asymmetric is slower, but it's great for identity and key exchange. So real systems use a hybrid approach. Asymmetric establishes trust and exchanges a session key, then symmetric encrypts the actual data. Symmetric equals fast bulk data, asymmetric equals trust plus key exchange, hybrid equals real world. Now let's connect it to real technology. You type an email. The computer turns your message into bits, ones and zeros. Then it travels down the network stack. TCP breaks it into pieces and ensures delivery. IP adds addresses so it can route across networks. Ethernet or Wi-Fi frames it for the local network. That traffic leaves your device, crosses your local switch and router, hits a firewall, and goes out to the ISP. That's north-south traffic, user to cloud or internet. When the message reaches the provider, there's often east-west traffic inside the data center. Mail gateway, spam filter, security scanning, archive, storage. And if TLS is enabled, the message content is protected as ciphertext while it travels, so eavesdroppers can't read it. North-south. User cloud, east-west, system-system. Key length is measured in bits. In general, longer keys are harder to brute force, but you compare key sizes within the same algorithm family. And remember, cryptography often fails not because the math is weak, but because of weak passwords, stolen keys, old algorithms, or bad configuration. Attackers love shortcuts. Crypto often fails at keys plus configuration level. Here's your final takeaway. Encrypt for secrecy, hash for integrity, sign for identity, PKI for trust. Then apply it to data in transit, data at rest, and data in use. If this helped you understand security clearly, like and subscribe. And if you want structured training, labs, and coaching, visit EmpowerTechPathway. We help students and professionals build real skills that translate to real jobs. Here's why this matters. Cryptography isn't just for exams. It protects your privacy, your money, your identity, and your career. So remember the blueprint. Encrypt, hash, sign, PKI. If you can map those to a scenario, you're thinking like a security professional. If you want more content like this, subscribe to EmpowerTechPathway and share this with someone who's learning cybersecurity. And comment, crypto, if you want me to post a free cheat sheet and practice questions based on today's video. I'll see you in the next video.